What's up, guys? Mr. Jones here, and we are going to be going over complex inequalities in this one. Something that we talked about already a little bit, but we talked about it in terms of absolute value. So in this one, we're just going to be going over normal inequalities, but that are complex, so without absolute value, okay? And what's nice is I already introduced you guys to kind of the difference between and or solutions and what those look like. But yeah, I'm just going to walk through a few examples of this, and we'll get into it. So number one is asking, what is the solution of 6x plus 5 is greater than or equal to 23, or 1 half x plus 9 is less than 8? Okay, so you see here, or, right? It lays out for you, this is going to be an or solution, right? And that's what a complex inequality is. It's one where we kind of have two different possibilities for the answer. And in the case of absolute value, right, the one we learned last time, right, we said or is when it would be either of the greater thans, right? In an absolute value inequality, where we kind of have to do a little bit more work to determine whether it's going to be an and or an or solution. But when they are not absolute value problems, oftentimes it'll just tell us straight up, right? Because with absolute value, we have to split the inequality up, and that's where we get our two solutions from. But when they are normal inequalities without an absolute value, right, we're not going to have two different solutions for each of these, right? We have two totally separate, totally different inequalities that we're going to solve separately. And that's where we get our two answers from, okay? And so this tells us or, right? And you see that they're both not greater than. So again, the greater than or equal to, or those rules that I said, those really only apply to absolute value inequalities, okay? So when there's not absolute value, again, you look for, it'll tell you, okay? It'll tell you which one it is, either an and or an or. But the number line, how it looks on the number line is going to be the same, okay? So hopefully you remember too, an or inequality is when our points or our solutions on the number line are kind of going away from each other, okay? So that's a way for you to check your answer. So this first one, 6x plus 5 is greater than or equal to 23. And again, I don't have to split this and do my, flipping around my inequality because this is not absolute value. So to isolate the x, I would minus 5 from both sides. And I would do 6x is greater than or equal to 18. Okay. And then I would divide by the 6 as my last step. And I would get x is greater than or equal to 3. Okay. And let's just graph that right now just because we got the answer. So x is greater than or equal to 3. What is that going to look like? Well, that is going to be a closed circle at positive 3. And again, when my variable is on the left side of my answer, I can kind of follow that arrow rule and say, okay, greater than is an arrow pointing to the right. So on my number line, it's also going to be pointing to the right. And again, now that you did that, and you know that it's an or problem, you know that this one should be, right, this point should be somewhere over here, and then with an arrow pointing that way, okay? So when you have that in your head going into it, you know you can expect what your answer should look like, okay? But let's get the exact answer here. Okay, same thing. I want to isolate the x, so I minus 9 from both sides, less than negative 1, okay? And then how do I cancel out this 1 half? Well, you could multiply by the reciprocal, right? And the reciprocal of 1 over 2 would be 2 over 1, and 2 over 1 is the same as just 2. So cancel out a half with a times 2. So I now have x is less than negative 1 times 2, negative 2. Okay, and let's see if that looks like what I thought it would before I solved it. And so I have an open circle, right, because there's no extra line underneath here. So there's no extra coloring on my number line. So open circle at negative 2. And then again, I can follow my arrow rule because my variable's here. Arrow pointing to the left. So yes, it does look like I thought it would, which is great. And that's what all or problems look like, is no overlap, right? Okay, moving on to number 2. What is the solution of 10 is less than 3x minus 2, which is less than 19? Okay, now I talked about this a little bit in the last video, okay? Kind of this all looks like one big thing with my inequalities here. And this is actually like a condensed way of saying two different problems, okay? And what I like to do, yes, you can technically kind of solve this at once by adding 2 to everything, but as we're first learning this, I do want to just break it up. So you see that there's 2 separate inequality signs. And so again, that's my indicator that, hey, this is 2 separate problems. So let's expand this, okay? So this right here is going to represent one problem, right? This middle part is kind of shared across both of them. And so this part right here is saying 10 is less than 3x minus 2. And you can keep it like that, but with inequalities, it is super helpful for me to have my variable on the left, okay? Again, it's not necessary, but I just like to do that for consistency. So I'm going to flip around all of it, okay? So I'm going to say 3x minus 2, flip my inequality sign to greater than 10, okay? Now that is my one inequality that I gather from this, okay? Now my second inequality is, again, that shared middle part with the second one. And I don't have to worry about flipping this one around, right? So I can just say 3x minus 2 is less than 19. So that is going to be a helpful way for me to write these. So it gives me 2 separate inequalities to solve. And you might be thinking, okay, is this going to be an and or an or? And that would be a great question if you're thinking that. And I mentioned it in the last video too, but this is true. Anytime you see just this single line with the 2 different inequality signs kind of written in this way, it is always going to be an and problem. Okay, it's always going to be and. Okay. And so again, what kind of like this one, what is it supposed to look like? That's super helpful to go over before you solve anything so you know what to expect for your answer. Okay. Again, and is different than or. Or is where they're kind of going in different directions, where and they're going in different directions, but there's overlap, right? So it's kind of one is going towards the other one, and the other one is going that way too. So there's overlap. In that overlapping section is the part that's the solution area. Okay. So I know that's kind of messy, but different than or. Okay, so you want the points, the arrows going towards each other for and. Okay, so let's see if it looks like that. So I solved this out. Okay, solved the first one. 3x minus 2 is greater than 10, so I plus 2 to both sides. 3x is greater than 12, and then I divide by 3, so x is greater than 4. X is greater than 4, so let's draw that sucker on the number line here. So I go to positive 4, again, open circle, and then I have that arrow pointing to the right. And again, that's why I did this flipping around, because when you go to draw this on the number line, it's super helpful to have your variable on the left with inequalities. Okay, so if you would have solved it this top way, again, you would have gotten the same answer, but you're prone to make more mistakes when you keep it like that. Now looking at this one, again, same thing. I solve for x, so I plus 2 to both sides, and I get 3x is less than 21, and I divide by 3, so x is less than 7 is my solution for that one, okay? And then here I have my point at 7, my open circle, and that again is an arrow going to the left, okay? And does it look how I wanted it to? Yes, we have an overlapping section. Okay, so with and, again, it can always be a little bit messier. So to just redraw that down below, this would be my solution area between 4 and 7. Okay, so there we go. There's some complex inequalities for you. Let me just do a couple more examples, and then we'll be all set. Okay, guys, first things first, I'm the realist. Sorry. First things first, I had complex written here. For the first 2 examples, the correct title of this is compound inequalities. That's what we're going over, compound inequalities, not complex, 2 similar words. So thanks for showing grace for me there with making that mistake. But anyway, I got number 3 here. It is compound and it is complex as well. So both are fitting, and we're going to solve this out. Okay. So you look at this, another long string of expressions kind of connected with these inequality symbols. And so this is an inequality that we can solve, okay? And it's a lot more complicated, right? Because we've got variables kind of throughout the inequalities, right? Every part of it has a variable in it, okay? So that's going to make it a little bit more complicated, but follow the same processes that we did before, okay? So first thing I want to think of, right, it doesn't tell me explicitly whether this is an and or an or problem. But remember, when it's a long string like this, it's always and. It's always and, okay? The first inequality that I'm going to have is these two, okay? And so again, just to write that, -6 plus 5x is less than or equal to 24 minus 10x, okay? That's what's included in the first one. Okay, I'm going to write my second one over here. And I said before, right, on the last example I did number 2 that was like this, I flipped it around, okay, because I wanted my variable on that left side. For this one, I don't have to make that change necessarily because the variable, there's variables on both sides. So I can actually leave it like this and it'll end up working out very well for me. But my second inequality that I'm going to have comes from, again, the shared middle part and then this second part here. So this is 24 minus 10x is less than or equal to 24 minus 6x, okay? And so now solving these out, okay, I want to cancel out one of my variable terms. So I'm going to plus 10x to cancel that, plus 10x over there. So once I do that, I have 6 plus 15x is less than or equal to 24, okay? So now I have a single variable term, and I can get that by itself, okay? So I plus 6 to both sides, okay? When I do that, I'm left with 15x is less than or equal to 30. And then I divide by 15 to both sides, and it ends up working out nice and neat for me. X is less than or equal to 2. I forgot to draw my number line. I will do that. I'll draw it after I solve the second one out, okay? So just solving this one's going to be interesting, okay? So I always start with canceling out one of your variable terms. So I'm going to cancel out this minus 6x with a plus 6x, okay? Because I always like canceling out the one on the right so that my variable ends up on the left, okay? So I'm left with 24 minus 4x, negative 10 plus 6, negative 4, is less than or equal to 24, okay? So watch this. My x term's here, so I want to cancel out this positive 24 by doing minus 24, right? 24 minus 24 is 0, it cancels. Put a minus 24 here, and a lot of kids look at this and they say, okay, 24 minus 24 cancels. And that's technically true, but a lot of kids will freeze up here and they'll say, oh, I don't have anything left over here, so I must be done, or it must be like no solution or something. Remember, something canceling doesn't mean, like, it does mean that the numbers go away, but really, I'm saying it's 0 there, right? So really, what's left would be 0 minus 4x is less than or equal to 0, okay? And the reason I don't write all the zeros in is because they're kind of unnecessary. They're not super helpful. But when there is nothing else on, right, if I cancel this one out too, there would be nothing else over there. And for it to be an equation, I need to have something on both sides, okay? So saying 0 minus 4x would just be negative 4x, and so I can just kind of get rid of the 0 there. But I should keep this 0, right? So these do cancel, but they cancel and they still give me 0, and I continue with the problem like normal. And then to finish this out, I divide by negative 4, okay? And 0 divided by negative 4, 0 divided by anything is just 0, okay? But look, you divided by a negative. It's easy to miss this too, right? You divided by a negative, and even though it ended up being 0, anytime you divide by a negative, you need to flip your sign around, okay? So x is greater than or equal to, right? Flipping that to be 0. So there's my two answers, okay? X is less than or equal to 2, x is greater than or equal to 0. Again, with and, hopefully you remember, again, these should be two overlapping points, right, with the arrows overlapping each other, okay? Let me sketch my number line real quick, and we'll see if that happens. So I have an easier number line here because it is two numbers that are pretty small. So x is less than or equal to 2. So I draw a closed circle because it is less than or equal to, and I draw an arrow going that way. And then x is greater than or equal to 0, closed circle here, arrow pointing to the right, so I draw it that way. And yes, I do have that overlapping area. It looks like it's supposed to. So there's a little bit on compound inequalities, not complex inequalities, but yeah, hopefully that makes sense. Thanks for watching. Great.